see on the board. Inshallah, today we are going to continue with the special functions, beta gamma functions. So let's start one question. You see here we have to prove beta of m comma n equals to beta of m plus 1 comma n plus beta of m comma n plus 1. We are going to use these two formulas which already we have discussed in the part 1. Okay, beta of m comma n, if you want to change into gamma, the formula will be gamma of m into gamma of n by gamma of n plus 1. One more formula we have to use here is gamma of n is n minus 1 gamma of n minus 1. Taking left hand side and bringing the right hand side is difficult. We have to start taking right hand side, we have to bring the formula, we have to bring the left hand side, we have to prove the left hand side. So I wrote the right hand side. Now let me change into gamma. Beta of m comma n is gamma of m into gamma of n by gamma of n plus. So we write like this: gamma of m into gamma of n divided by gamma of m plus n. I'm writing like this: m plus n plus 1. Here also gamma of m into gamma of n divided by gamma of m plus n. M plus n. Now see here, let me change here. We are going to use 2 3 formulas here. See here, let me show in bracket. Now we can write gamma of m plus 1 equals to, let me use this formula. Gamma of n is n minus 1 gamma of n minus 1. N minus 1 gamma of n minus 1. Let me use this formula. So gamma of m plus 1, let me change this one. This will be m minus 1 gamma of m minus 1. This plus 1 m minus 1 will get cancelled, we get m into gamma of m. In the same way, let me change this one. We are not changing this, we are changing this. Here also don't change this, change this one. Gamma of n plus 1 equals to n minus 1 gamma of n minus 1 plus 1 will get cancelled. Now what is left here? N into gamma of n. Lastly, let me change this also, this two. This is gamma of n. Gamma of n is n minus 1 gamma of n minus 1. So plus 1 minus 1 will get cancelled, left with m plus n gamma of m plus n. So let me change this all. See here, equals to, now watch carefully. Gamma of m plus 1 we have changed, we got this as m into gamma of m. This is gamma of n divided by this, we already changed, we got this one, m plus n gamma of m plus n. Plus, similarly here let me change. Gamma of m you write as it is, gamma of m. This is n into gamma of n divided by, denominator is m plus n gamma of m plus n. Now let me do one thing, let me take common from numerator and denominator. In both numerator and denominator we are having gamma of m gamma of n, and in denominator we are having gamma of m plus n. Now what is left here? Here it is left with m by m plus n. Here we left with n by m plus n. Now let me take LCM here. Now see here, this is the formula of beta of m comma n. Gamma of m into gamma of n by gamma of m plus n is nothing but the formula of beta of m comma n. If we take LCM here, m plus n, in the numerator also will get m plus n. Now this will get cancelled in 1. So we left with beta of m comma n. So this is the answer we required. So next question you see here, integration 0 to 1 x power m into 1 minus x power p whole power n dx. Hence this means using this, whatever the answer we get from this, using this answer we have to prove this one. Integration 0 to 1 x power 3 by 2. First let me find this, then comparing the values we will get the other answer. So I am starting from here. Integration 0 to 1 x power m 1 minus x power p whole power n dx. In the previous class already we have learned that here whatever the term will be there, it should not have power here. So we have to start like this, put x power p should equals to y. So here we should take out this p. So for that x power p equals to y. If you bring p here, it will be 1 by p. X equals to y power 1 by p. Now you differentiate it. X, the differentiation of x will be dx. We know d by dx of x power n is n into x power n minus 1 dy. D by dx of x power n is n into dx power n minus 1. So we got this one. In place of dx we write this, in place of x we write this, in place of x power. You see here there is no change in the limits. If you put x equals to 0, y will be 0. If you put x equals to 1, y will be 1. So no change. Now I'm changing the question. Integration limits remains the same, 0 to 1 x. The value of x is y power 1 by p power m into 1 minus x power p is y, x power p is y, then power n dx. Sorry, dx. In place of dx we write the value of dx is 1 by p y power 1 by p minus 1 dy. Now this is constant, we take out of this is constant, we have written outside the limits, 0 to 1. Multiply this one, this will become y power m into 1 m by p. You write with this y also, because next step base is same, we can add the powers, 1 by p minus 1 into 1 minus y power p dy. So the next step will be, this bases are same, so add the powers. Bases are same, we have to add the powers. How to add the powers? You see here, if you add this one, m by p plus 1 by p minus 1, you take LCM for this 2p, it will become m plus 1. So we can write like this, 1 by p integration 0 to 1 y power m by, sorry, m plus 1 by p, m plus 1 by p minus 1 into 1 minus y power p dy. Now if you recall the formula, what is the formula we are having? X power m minus 1 integration 0 to 1 1 minus x power n minus 1 dx equals to beta of m comma n. Now one, just we are having, you see here we are already having minus 1 here. We are already having minus 1 here. We must bring minus 1 here. To bring minus 1 here, you add 1 and subtract. Add 1 and subtract. So it is the formula, exact formula. 0 to 1 x power m minus 1 1 minus x power n minus 1 is beta of m comma n. In place of m you are having m plus 1 by p comma n. In place of n you are having p plus 1. So we got the answer now. Now see here, therefore integration 0 to 1 x power m into 1 minus x power p whole power n dx equals to, we got these answers, 1 by p beta of m plus 1 by p comma p plus 1. Now let me continue this one. Now using this, the question is to find 0 to 1 x power 3 by 2 into 1 minus root x. If you take out the root here, it will be 1 by 2 power n. In place of n also we are having 1 by 2 dx. Now let me compare and substitute the values. In place of m we are having 3 by 2. In place of p 1 by 2. In place of n 1 by 2. See here, 1 by p. P the value is 1 by 2. Beta of m. In place of m we are having 3 by 2 plus 1 by p is, the value of p is 1 by 2 comma 1 by 2 p is plus 1. This 2 will come in the numerator. I'm writing here 2 into beta of, you see here, if we take LCM, what will happen? 2 ones are 2, 2 plus 3 5, 5 by 2 by 2 will get cancelled, we get just 5. 3 2 ones are 2, 2 plus 3 5 by 2 by 1 by 2, 2 2 will get cancelled, 5. Now if you take LCM, 2 ones are 2, 2 plus 1 3 by 2. Now at last let me change this into gamma. This will be gamma of m into gamma of n divided by gamma of m plus n. In the previous class, we have studied about the how to find the values of gamma. For integers, the value of gamma is n minus 1 factorial. N minus 1. This is 5 is an integer, so 5 minus 1 will be 4 factorial. For 3 by 2, I already shown you how to find the gamma of 3 by 2. Reduced by 2, 3 minus 2 will be 1, 1 by 2 into root pi. In the same way, let me change this one also, gamma of, we take LCM, 2 4s are 5 2s are 10, 10 plus 11, 13 by 2. Once more you see here, 2 5s are 10. Okay, here see here, 2 into 4 factorial, 4 factorial is 24. Okay, let me cancel this one. See here, we can cancel this 2 2. 4 factorial is 24 root pi divided by. Now we already seen the last class. We already seen in the last class how to solve the value of 13 by 2, gamma of 13 by 2. Reduce by 2, it will be 11. So 11 by 2 into 9 by 2 into 7 by 2 into 5 by 2, 3 by 2, 1 by 2, at lastly root pi. Lastly root pi. So this root pi will get cancelled, and you see anything is cancelling. You do one thing, 24 into, you bring this upside, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64 into 64 divided by 11 into 9 into 5 into 3 into 1. 11 into 9 into, sorry, 7, 7 into 5 into 3 into 1. So we can take out this value from the calcium. If you take out the value from the calcium, you'll get the answer. You see here, let me start. Let me use the symbol of division. Here you will have the symbol of division. So let me take the division. Let me take the division. See here, in the numerator you are having 24 into 64 divided by, in the in denominator 11 into 9 sevens 63 into 15. So you will get the answer as, the answer of this is 512. 512 divided by 3465. 512 by 3465. Now see on the board, I have wrote some few questions written on the board. See here, whenever we get sine, cos, or sine or cos or tan, whatever, tan or cot, let me use this formula. Whatever we already written this formula, integration 0 to pi by 2 sine power n theta cos power n theta d theta equals to 1 by 2 into beta of m plus 1 by 2 n plus 1 by 2. Now carefully you understand this one. Whenever we get the questions in terms of sine cos or tan cot, whatever, we can change tan also sine by cos. So we have to do questions based on this formula. So let us start the first one. That formula, this is integration 0 to pi by 2 sine power 3 theta cos power 5 theta d theta equals to, you see that in place of m we write 3, in place of n we can write 5. So this is 1 by 2 beta of m. In place of m is 3, 3 plus 1 by 2, comma in place of n is 5, 5 plus 1 by 2. Let me solve this one. 1 by 2 into beta of 3 plus 1 is 4. 4 by 2 will be 2. 4 by 2 will be 2. 6 by 2 will be 3. Now let me change into gamma. This will be gamma of m into gamma of n by gamma of n plus n. We already know that gamma of n for integers is n minus 1 factorial. This is 2. 2 minus 1 is 1 factorial. 3. 3 minus 1 is 2 factorial. Divided by 5 minus 1 is 4 factorial. Now this 2 factorial will be 2. 2. 2 will get cancelled. 1 divided by 4 factorial is 24. 4 factorial is 24. Now let me try the second question. Integration of 0 to pi by 2 dx by root x. In the same way, third question you practice by yourself, that is cos x. Okay, you do one thing, you take out the root, so it will be like this, 0 to pi by 2 dx divided by sine power 1 by 2 x. If you take out the root, it will be 1 by 2. Bring this in the numerator, it will become minus 0 to pi by 2 sine power minus 1 by 2 x dx. Now to use the formula, we must have sine and cos. We don't have cos here, but we can write here cos power 0x, because cos power 0x will be 1. So let me write into the formula. You see here, integration 0 to pi by 2. We already having sine power minus 1 by 2 dx. Sorry, sine power minus 1 by 2 x. We don't have cos, so write cos power 0 x dx. Now it changes to formula. What is our formula? Integration 0 to pi, integration 0 to pi by 2 sine power m theta cos power n theta e d theta equals to 1 by 2 beta of m plus 1 by 2 n plus 1 by 2. So let me use this formula, equals to 1 by 2 beta of m plus 1 by 2 comma n plus 1 by 2. 2 ones are 2, 2 minus 1 will be 1, 1 by 2 will become by 4. This will be 1 by 2 beta of 2 ones are 2, 2 minus 1 1, 1 by 2 will be 1 by 4. comma 1 by 2. So whenever we change this, whenever after completing into the beta, we must change it to gamma. So 1 by 2 into this will be gamma of m into gamma of n divided by gamma of m plus n, 1 by 4 plus 1 by 2. So let me leave here itself 1 by 2. To just we change one thing, gamma of half is root pi. So this is root pi into gamma of 1 by 4 divided by gamma of, if you take LCM here 4, 2 plus 1 will be 3. So this will be 3 by 4. This is 3 by 4. So let me do one more question. Now see here, integration 0 to pi by 2 tan x dx equals to pi by root 2. Even if you get cot x also, the formula will be same. Now let me start with the left hand side. Integration 0 to pi by 2 under root of tan x. Now we know tan can be written as sine by cos 0 to pi by 2 under root of sine x by cos x dx. You know, if you take out a root, it will become, power will become half. Integration 0 to pi by 2. This will become sine power 1 by 2 x divided by cos power 1 by 2 x dx. Bring this cos in the numerator, the formula will become like this. Integration 0 to pi by 2 sine power 1 by 2 x. If we bring cos in the numerator, it will be cos power minus 1 by 2 x dx. Now let me use the formula sine power m cos power n will be, its formula is 1 by 2 into beta of m plus 1 by 2 comma n plus 1 by 2. Now let me continue this one, 1 by 2 into beta of, if you take LCM, 2 ones are 2, 2 plus 1, 3 by 2, 3 by 2 by 2 will become by 4. Let me write that 3 by 4. 2 ones are 2 plus 1 is 3, 3 by 2 by 2 will become by 4. 2 ones are 2, 2 minus 1, 1 by 2 by 2 by 4. Now just whenever we get in terms of beta, we change in terms of gamma. So this will be gamma of m, gamma of m into gamma of n divided by gamma of m plus n. Now see here, 3 by 4 plus 1 by 4 will be 4 by 4. It is 1. So this value is 1. So let me change this one, half of gamma of 3 by 4 into gamma of 1 by 4 by gamma of 1 is 1. Next step. You see here, there is a relation between these two. If you minus 1 minus 1 by 4 will be 3 by 4. You see here, 1 minus 1 by 4 will be 4 ones of 4. 4 minus 1, 3 by 4. So whenever there is a relation that 1 minus this value will become this, or 1 minus this value will become this, we will use this formula. So there is a formula, gamma of n into gamma of 1 minus n. If we get like this, n 1 minus n 1 minus n, we can write this as pi by sine n pi. So let me use this formula, 1 by 2 into, you see here, gamma of 1 is 1, leave this one. I am writing first this, gamma of 1 by 4. 3 by 4 we can write like this, 1 minus 1 by 4. It is same, 4 ones of 4, 4 minus 1, 3 by 4. So this is 3 by 4, this is, it is of the formula like this, gamma of n into gamma of 1 minus n. Its formula is pi by sine n pi. In place of n we are having 1 by 4 into pi. This is pi by 4, 45 degrees. Sine 45 degrees, we can substitute the value, 1 by 2 into pi by sine 45 degrees is 1 by root 2. Bring this root 2 in the numerator, it will be root 2 pi by 2. Now change root 2 pi by, we can write 2 in terms of root 2 into root 2. So root 2 to get cancelled, this is pi by root 2. So this is the answer we have to get. See here on the board, integration 0 to infinity x power 4 into 1 plus x power 5 by 1 plus x power 15 equals to 1 by 5005. These two questions are same. I am doing this one. You practice this by yourself. Only the difference is here we are having plus, here we are having minus. Because of minus, the plus and minus term will get cancelled. You will get the value of 0. You get the value 0. Here both will be plus. Let me see how to solve. You see, I am writing the question. Integration 0 to infinity x power 4 into 1 plus x power 5 divided by 1 plus x power 15 dx. Now see the next step. Let me multiply this, x power 4 into 1, x power 4 plus x power 4, sorry, here we are having 5 here. X power 4 into x power 5 will be x power 9 divided by 1 plus x power 15 dx. So the next step is you separate x power 4 and x power 9 with the denominators. So you'll get two integrations. Integration 0 to infinity x power 4 by 1 plus x power 15 dx separated, plus integration 0 to infinity x power 9 x power 9 divided by 1 plus x power 15 dx. Now watch carefully. What is the difference? You see, we can use this formula. Watch carefully. We must remember this one. We are having one formula like this. Integration 0 to infinity x power m minus 1 divided by 1 plus x power m plus n dx. This is the formula for beta of m comma. This is a particular formula, just there are only 2-3 questions where you use this formula. So according to this, we must have minus 1 in the numerator. To make the formula, we must have minus 1. So 4 can be written as 5 minus 1. 4 can be written as 5 minus 1. See here, x power, in place of 4 you write 5 minus 1. When we are changing here 5 minus 1, we are having 5 here, no? So change this also in terms of 5. 15 also in terms of 5. 15 in terms of 5, we can write 5 plus 10 dx, plus integration 0 to infinity x power. You also write minus 1, so 9 can be written as 10 minus 1 by 1 plus x power. You have to change in terms of 10, so we can write like this, 10 plus 5. Now this is the formula of beta of m comma n. This is the formula of beta of m is 5 here. Suppose m comma n 10 plus beta of m comma n 10 comma 5. We know there is a formula beta of m comma n equals to beta of n comma n. So we can interchange this one. Let me interchange the two become same. Beta of 5 comma 10 plus, now interchange this one, beta of m comma n is nothing but beta of n comma n. Now this we can add, x plus x is 2x. In the same way, this will become 2 into beta of 5 comma n. Now let me change into gamma. 2 into, this will be gamma of m into gamma of n divided by gamma of m plus n. We know what is the formula for integers. Gamma of n will be n minus 1 factorial. For integers, gamma of n is n minus 1 factorial. So this will be 4 factorial into gamma of 10 will be 9 factorial divided by gamma of 15 will be 14 factorial. In the next question, only the difference is in place of plus you are having minus. In place of plus you are having minus. The second question, this plus and minus will get cancelled, you get the answer 0. Now let me see here. Let me see in the next question. We can take out this from the calci. Now you use the division symbol first. Now in the numerator you are having 2 into 4 factorial. Factorial is somewhere here, is here. 4 factorial into then 9 factorial. 9 shift, you see factorial is here, 9 factorial divided by 14 factorial, 14 shift factorial. So you get the answer as 1 by 5005. So this is the answer we required. See here, let me continue this one. Let me start like this. See, we are having one formula beta of m comma n equals to integration 0 to infinity. We are using this formula because it is like this only. We are having this formula x power m minus 1 by 1 plus x power m plus n. We have already written this formula in the last class. Now let me use this formula to prove this formula, this value. You see here you are having in formula 0 to infinity, but here you are having 0 to 1. See here 0 to infinity is 0 to 1. So let me change this 0 to infinity. I'll explain you. Suppose we are having limits 0. Suppose here we are having 1. This is infinity. So let me change 0 to infinity to 0 to 1 and 1 to infinity. 0 to 1 and 1 to infinity. 0 to 1, we are changing this one, x power m minus 1 by 1 plus x power m plus n dx plus 1 to infinity. 1 to infinity. Why we are changing? Because we want 0 to 1. 0 to 1 plus 1 to infinity x power m minus 1 by 1 plus x power m plus n dx. That I am denoting this as 1 because we already got this one. We should not change this one till the last step. This we already got 0 to 1 x power, this value we got. Now we have to solve this one. Let me solve this separately. Okay, solving integration 1 to infinity x power m minus 1 by 1 plus x power m plus 1. Let me solve this completely, then let me substitute this value here. Let me solve this separately. After that, let me substitute this one. Now how to change this one? Watch carefully. There is a method for here. You put x equals to 1 by y, x equals to 1 by y. Now differentiate this one. X will be dx. D by dx of 1 by x is minus 1 by x square. So d by dy of y will be minus 1 by y square dy. No, this is x and this is dx. Now the value of limits will also change here. Watch carefully. Bring this y here, x here. You can write like this: y equals to 1 by x. Now you put x equals to 1, lower limit x equals to 1. So you get y equals to 1 by 1, that is 1. This is the lower limit. Now you put x equals to infinity. If you put x equals to infinity, y equals to 1 by infinity is 0. So this is the upper limit. This is the upper limit. Now this will change as you see here. Now we are changing this completely. Equals to limits 1 to infinity. Now it becomes 1 to 0. 1 to 0. In place of x we kept y, 1 by y power m minus 1 divided by 1 plus 1 by y. X is 1 by y power m plus n. Now into dx. The value of dx is minus 1 by y square dy. Now see here, let me do one thing, integration. If you take out this minus, this will change, interchange. 0 will come here in the lower limit and 1 will come in the upper. So I am taking out minus, so this will become 0 to 1, 0 to 1. Now watch carefully. 1 power any number will be 1, 1 divided by, I am writing this y here, y power m minus 1, y power m minus 1. Next one is here, you see, when we take LCM, y into 1 will be 1, this will be y into n will be y plus 1 by y power m plus n. Now one thing is left here, into y square dy. Okay, now let me separate all the terms. You see here, equals to integration 0 to 1, 1 divided by, these two are bases same, these two are bases same. If you add m minus 1 plus 2 will be m plus 1. This will be y power m plus 1, y power m minus 1 plus 2. Now this you separate the powers of numerator denominator. This will become 1 plus y power m plus n divided by y power m plus n dy. Now few steps are left. You see here, equals to, these two are same. We can cancel this one. You do one thing. This will come in the numerator. This will come in the numerator. Denominator is numerator. So you write this here. Integration 0 to 1, this will become y power m plus n. Now you bring this in the numerator, this plus m will become minus m, this plus 1 will become minus 1. So this will be minus m minus 1 divided by 1 plus y power m plus n dy. Now the last steps. So you see here, plus m minus m cancel. Integration 0 to 1, y power n minus 1 divided by 1 plus y power m plus n. Now we can change the variable. In place of y, you do one thing. In place of y, you write x. We can change the variable. The same formula we can write in terms of x. 0 to 1, x power n minus 1 by 1 plus x power m plus n. Now let me substitute this in 1. Substituting in 1. In 1, what we are having is, see here, is the value of 1. The first equation we have 0 to 1, x power m minus 1 by 1 plus x power m plus n dx. Now in the next one we solve, now we got this one, 0 to 1, x power n minus 1 by 1 plus x power m plus 1. Since the limits are same, denominators are same, let me take the LCM. 0 to 1. Now if you take LCM, it will be 1 plus x in the denominator power m plus n, and the numerator is here x power m minus 1 plus here numerator is x power n minus 1 whole dx. So we got the answer. You try these questions by yourself. Okay, inshallah we are going to continue in the next class, inshallah.